until fairly recently, asteroids have been a neglected area of planetary science. In some ways, they're easier to get to than a lot of the planets. There's a lot to be learned there. It's refreshing to see more attention to them.
So Henry, what's your reaction to the different announcements that have come out with Deep Space Industries and Planetary Resources, and even B612? I can't remember what they're called.
It's interesting. It's encouraging to see interest in the area. It's ambitious to hope for a financial return from it anytime soon. And I really hope they can find the funding they're looking for. It's a very promising sign, but it's very early days yet. There's a long row to hoe before we get to the point of actually being able to do asteroid mining. And it will be interesting to see if they can get investors who are patient enough to wait for the sort of results they may get eventually over time. It's not something it's easy to find, that kind of patient investment money. You really want people who are buying into a dream rather than hoping to multiply their money quickly. And there's a lot less buying into a dream money than money multiplying money. So yeah, it's very nice to see. I hope they succeed. They're a long way from making big profits, I fear.
Which approach do you think is better?
I think it's worth trying more than one, is the fast answer. It's hard to tell at this point. We've tried the government exploration angle. It's gotten us some results. It has a problem with maintaining constant purposes over time. The planetary missions in the last decade or two have been very much a grab bag rather than a coherent program. There's been little follow-up on interesting results, or on, for that matter, on failures that deserve to be reflown. A commercial venture could perhaps be more persistent in pursuing its goals, more willing to keep trying if things went wrong. On the other hand, it's also got a narrower focus and perhaps less willingness to talk about the details. It'd be good to have a mixture. It'd be interesting to see what happens.
As far as being able to study these asteroids more in detail, do you feel that it's smarter to start off with, like, say, Planetary Resources plan to use orbital telescopes to categorize these first, or more of a Deep Space Industries plan to start sending prospectors to orbit these things close up right away?
I think there's very limited mileage to be had from telescopes in Earth orbit. There's a few things they can do well. In particular, they can look closer to the sun than observers on Earth, who are hampered by all this annoying daylight. But to actually start learning about specific asteroids very quickly, you end up having to get close to them. I think Planetary Resources may be using its orbiting telescopes more as practice for its team than because they hope to get a lot of information from them. They are explicitly saying that this is sort of the prototypes for things that are going to go out and get a closer look at the asteroids. And I think for actual useful information, they're going to want to move out from Earth orbit fairly quickly if they can. On the other hand, it's a good thing to get some practice first and debug some of the hardware in Earth orbit. As I said, when you try a bunch of new things for the first time, there's a pretty good chance it's going to fail. Getting some of that out of the way in a cheaper and easier to work with environment is not a bad thing.
Do you feel that there are small things that could be done before and after NASA's plan to orbit an asteroid, if that's successful, that either Planetary Resources or Deep Space Industries or a new venture or even a private individual could do on the cheap to be able to collect as much information as they could?
For actual space missions, it's hard to do deep space missions on the cheap. The communications are hard. We've actually looked some at doing very small deep space missions, and communications keep being the big headache. A small spacecraft has not very large solar arrays, so very limited power to run a transmitter. Not very large antennas, so the output from the transmitter can't be formed into a narrow beam very well. It's hard to get a lot of data down to the ground from one. As far as small things that could be done without talking spacecraft specifically, the asteroid search programs on Earth are chronically underfunded. And a lot of the asteroids they find are lost, or at least aren't followed up in detail, because follow-up work is even more underfunded. Getting things like even just enough tracking to make sure we have the orbit of each asteroid nailed down isn't always done, because there's a shortage of telescope time for it. Getting things like spectra to get some idea of the nature of the asteroid and so forth. That information is even scarcer again because there's no telescope time for it. Quite modest investments in better searches and better search follow-up on Earth, where the equipment is cheap and can be maintained, would go a long way to improving our knowledge of these things.